The universe is not just vast, it's stranger, darker, and more astonishing than anything we could imagine. Tonight, I'll take you on a journey through 100 mind-blowing facts about space. From planets that rain glass sideways to stars so dense a teaspoon would outweigh a mountain. From galaxies colliding in slow motion to the final death of the universe itself. These are not just random facts. Each one is a reminder that reality is far bigger, far weirder, and far more fragile than it seems when we look up at the night sky. So, are you ready to question everything you thought you knew about the cosmos? Planets and moons. Let's begin close to home, with the worlds of our solar system. You think Earth is unique? Let's see how bizarre its neighbors truly are. On Venus, a single day lasts longer than an entire year. Imagine waking up and realizing the sun won't set for months. Could humans even survive such endless daylight and night? Jupiter, our giant protector, is so massive that more than 1,300 Earths could fit inside it. Yet this colossus spins so fast that a day there is less than 10 hours long. And what about Saturn? Its iconic rings look eternal, but they're disappearing. In about 100 million years, they'll be gone forever. Will anyone be around to miss them? Mars boasts Olympus Mons, the largest volcano in the solar system, 3 times the height of Everest. Imagine standing at its base. The mountain would stretch beyond the horizon. Then there's Neptune, where winds scream faster than the speed of sound. What would it feel like to stand in a storm that could shred steel in seconds? Mercury swings between fire and ice 430 C in the day, 180 C at night, because it has no atmosphere to hold the heat. And hidden beneath the icy crust of Europa, a moon of Jupiter, there may be an ocean deeper than all of Earth's combined. Could alien life be swimming in the darkness right now? On Titan, Saturn's moon, rivers and lakes of liquid methane flow under orange skies. It's a world where it literally rains gasoline. Even moons can surprise. Ganymede is larger than Mercury itself, while Pluto, once called a planet, has a heart-shaped glacier of nitrogen ice, silently beating in the darkness. And did you know? Earth's own moon is drifting away, slowly escaping our gravity, centimeter by centimeter. One day, eclipses will no longer exist. But perhaps the strangest worlds are those not tied to any star at all. The rogue planets, drifting alone in the endless night, forever homeless. Which of these alien worlds would you dare to visit first? Stars and the sun. Our sun feels enormous, but it's just an ordinary yellow star, one among hundreds of billions. It holds 99.8% of the solar system's mass, yet compared to others, it's nothing special. Imagine holding a teaspoon of matter from a neutron star. It would weigh 1 billion tons. That's like trying to balance Mount Everest in the palm of your hand. Some stars are cosmic monsters. Scuti, one of the largest known, could swallow more than 1,700 suns inside it. Others are tiny but terrifying. Magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's. One nearby could erase every credit card on Earth in seconds. And then there are the lighthouses of space. Pulsars, spinning hundreds of times per second, firing beams of radiation that sweep across the cosmos. Stars live, they burn, and eventually, they die. The death of a massive star is a supernova, an explosion so bright it can outshine entire galaxies. For a moment, night turns into day. When two neutron stars collide, the universe forges gold and other heavy elements. Yes, the jewelry you wear was once created in a cosmic collision. Look up at Betelgeuse, the red supergiant in Orion. It's so huge that if placed in our solar system, it would swallow Mars. And one day soon, maybe tomorrow, maybe a million years from now, it will explode. And not all stars die quietly. Some unleash hypernovas, releasing more energy in seconds than our sun will in its entire lifetime. Even stranger, some stars are runaways, shot out of galaxies at millions of kilometers per hour, doomed to wander intergalactic space forever. So tell me, do stars die, or do they simply change into something new? Galaxies and black holes. The Milky Way, our home galaxy, is a sprawling city of stars, with perhaps 400 billion suns, but even this giant is just one among trillions. And it's not alone. The Andromeda Galaxy is racing toward us. In 4 billion years, the two will collide, merging into a titanic cosmic city. What will the night sky look like then? At the heart of most galaxies lurk monsters, black holes. The one in our galaxy, Sagittarius A, is 4 million times the mass of the Sun. Fall into it, and time itself slows to a crawl. But black holes aren't just destroyers. Some fire jets of energy thousands of light years long, shaping entire galaxies. And then there are the real beacons, quasars, galaxies powered by ravenous black holes, shining brighter than all their stars combined. Galaxies weave together into structures unimaginably vast, clusters, superclusters, filaments forming a cosmic web that stretches across the universe like neurons in a brain. Yet even in this grand tapestry, there are holes, voids billions of light years wide, almost completely empty. If galaxies form a cosmic web, does that mean the universe itself is alive? Exoplanet and cosmic wonders. Beyond our solar system, the universe becomes even stranger. Astronomers now believe there are more planets than stars. Imagine that, every point of light you see in the sky may hide entire families of alien worlds. Some are hot Jupiters, gas giants orbiting so close to their stars that their atmospheres boil away. Others are super-Earths, rocky worlds bigger than our own, perhaps with continents and oceans. Some planets orbit not one star, but two, just like Tatooine from Star Wars. Others wander the galaxy alone, cut off from any sun. The TRAPPIST-1 system has 7 Earth-sized worlds, 3 in the habitable zone. Could this be the best place to search for life? Some worlds are covered in endless oceans, others scorched into seas of lava. On WASP-76b, iron literally rains from the sky. If there are more planets than stars, how many versions of Earth could be out there, waiting? Cosmic time and the fate of the universe. Finally, let's zoom out as far as we can to time itself. The universe is 13.8 billion years old. The observable cosmos stretches 93 billion light years across. And yet, this might be just a fraction of all that exists. Looking far in space means looking back in time. The light from the most distant galaxies left them billions of years ago, when the universe was young. In the far future, stars will fade, galaxies will die, and only black holes will remain. But even they are not eternal. Slowly, they evaporate, leaking radiation until nothing is left. This is the so-called heat death, a future of endless darkness. Or perhaps the universe will collapse back into itself in a big crunch, or tear apart in a violent big rip. Some believe our universe is just one bubble in an infinite multiverse. If that's true, then even the end may only be the beginning. So, how big is the universe really? Big enough to make us feel small, yet curious enough to keep asking questions. Final reflection. We've traveled from nearby planets to distant galaxies, from stars that forge gold to black holes that warp time. 100 facts, each one stranger than the last, all leading to a single truth. The universe is vast beyond imagination. And yet, in all this immensity, here you are, listening, wondering, searching. Maybe our size doesn't matter. Maybe curiosity itself is the greatest force in the cosmos. Subscribe if you're one of those who still wonders about the universe.
Imagine a vast ocean of stars, planets, dust, and gas that come together in a giant spiral. This is our galactic home, the Milky Way. The Milky Way is one of the trillions of galaxies in the universe, but it's special to us because it's where our solar system is located. The Milky Way is a spiral galaxy, and its shape resembles a huge star funnel with a central convex core and long, elegantly twisted arms. At the center of our galaxy hides a giant black hole called Sagittarius A*. It has a mass of over 4 million suns and holds all the stars and planets in the Milky Way together with its gravitational field. Our galaxy is about 100,000 light-years in diameter. This means that it takes light 100,000 years to travel from one edge of the galaxy to the other. There are over 200 billion stars in the Milky Way, and it is possible that each of them has its own system of planets like ours. Our solar system is located about 27,000 light-years from the center of the galaxy, in one of its arms, known as the Orion Arm. We make a complete revolution around the center of the galaxy in about 225 to 250 million years. That is, the last time our sun was at this same point in the galaxy was when dinosaurs first started appearing on Earth. The appearance of the Milky Way in the night sky resembles a thin strip of light made up of billions of stars. If you are far away from city lights and pollution, you can see this amazing sight with your own eyes. Interestingly, there are also several satellite galaxies in our galaxy. The Small and Large Magellanic Cloud. These are small galaxies that move around the Milky Way and may one day merge with it, adding more stars and matter to its mass. The Milky Way is not just a place where we live. It is a complex and dynamic system full of mysteries and amazing phenomena. And while we know a lot about it, even more remains a mystery. Who knows what amazing discoveries await us in the future? Subscribe to the channel and like it to not miss new videos about space and the universe. A lot more interesting things are ahead of us. Hello to all space lovers! Today, we are going to solve one of the most interesting and often asked riddles about the Moon: why it is always turned to the Earth one side. This phenomenon is familiar to everyone who has looked at the Moon at least once. We always see the same side of it, no matter where, and when we observe it in the sky. But how is this possible? What makes the Moon behave in such an unusual way? To answer this question, we need to delve into the physics of planetary and satellite motion, as well as the history of the formation of our solar system. To understand why the Moon is always turned to one side of the Earth, let's start with its origin. About 4.5 billion years ago, the Moon was formed by a colossal collision between Earth and a Mars-sized planet that scientists call Theia. This collision threw a huge amount of debris into orbit around the Earth, and over millions of years, this debris coalesced into what we call the Moon today. Since its formation, the Moon, like all celestial bodies, has rotated on its axis. But over billions of years, its rotation was slowed by the gravitational influence of the Earth. It is this slowing down that has put the Moon in what is known as a state of synchronous rotation. Synchronous rotation is a phenomenon in which the period of rotation of an object around its axis is equal to the period of its revolution around another object. In our case, the Moon makes one complete revolution around its axis in the same amount of time it circles the Earth, about 27.3 Earth days. This is why we always see the same side of the Moon. This is not a unique phenomenon in space. Many satellites of planets in the solar system, such as the satellites of Jupiter and Saturn, are also in a state of synchronized rotation with their planets. But what causes the Moon to slow down its rotation and stop on the same phase in relation to the Earth? The answer lies in the gravitational interaction between the Earth and the Moon. The Earth, being much larger and more massive, exerts a strong gravitational influence on the Moon. This interaction causes what are called tides and ebbs in the Moon's interior, just as the Moon causes the oceans on Earth to ebb and flow. When the Moon was spinning faster, its shape was slightly elongated because of Earth's tidal forces. Earth's gravity was constantly pulling on this elongated part of the Moon, trying to straighten it out. Over time, this gravitational friction slowed the Moon's rotation until it coincided with its orbital motion. At this state, the gravitational tide stabilized and the Moon froze in its position. It now always points one way to the Earth. Perhaps the question arises, if the Moon is always turned to the Earth on one side, does that mean it does not rotate on its axis? The answer is no. The Moon does rotate on its axis. It just does so at the same rate that it rotates around the Earth. If the Moon were not rotating, we would see all sides of it as it orbits the Earth. However, due to synchronized rotation, it remains looking one side. Another interesting phenomenon associated with the synchronous rotation of the Moon is its so-called far or back side. Many people mistakenly call it the dark side, but it is not. The far side of the Moon receives as much sunlight as the side we see. However, because of its synchronized rotation, people from Earth never see this back side. It has only been explored by spacecraft. The first spacecraft to film the backside of the Moon was the Soviet Luna 3 in 1959. Today, the backside of the Moon is being studied in much greater detail. And in the future, it could be a place for scientific bases because there is less radio interference from Earth, making it an ideal place for space observatories. Although the Moon seems constant and stable to us, its orbit is slowly changing. Each year, the Moon moves away from the Earth by 3.8 centimeters. This is because tidal forces between the Earth and the Moon transfer some of the orbital energy from the Moon to the Earth, slowing our planet's rotation and increasing the radius of the Moon's orbit. Over time, this may lead to the Earth and Moon reaching another amazing state. Their days and years will become equal, and both planets will always be turned to the same side of each other. Now let's talk about what we see on the visible side of the Moon. This lunar landscape includes large dark areas that are called seas, although they are actually giant ancient lava plains. The Moon's seas were formed after asteroid impacts, when liquid magma rose to the surface through cracks in the crust. In addition, numerous craters can be seen on the Moon, which were created by comet and asteroid impacts over billions of years. These details on the visible side of the Moon are what make it so recognizable to us. This is the side that humans have always seen from Earth, and it is the side on which the Apollo mission astronauts landed in 1969. So, now you know why the Moon is always turned to one side of the Earth. This is the result of billions of years of gravitational interaction between the Earth and the Moon, resulting in a synchronized rotation. Even though we always see the same side of the Moon, its backside remains just as important an object of study for us. Don't forget that our cosmic neighborhood is full of mysteries, and the Moon is just one of the many wonders that continue to inspire scientists and astronomers around the world. If you enjoyed this video, don't forget to subscribe to the channel, give it a like and click on the bell so you don't miss new exciting episodes about space. Thanks for watching, and see you soon!
What if the Moon is not what it seems? For thousands of years, the Moon has been a source of inspiration, mystery, and legend for mankind. But what if I told you that the Moon could be an artificial object? What if our Moon is not just a natural satellite of the Earth, but a giant ship created millions of years ago? In this video, we will look at the most shocking facts and mysterious anomalies of the Moon that question its usual explanation. Unexplained lunar anomalies. Why does the Moon sound like an empty sphere? The theory of the Moon's artificial origin. What do scientists and conspiracy theorists think? Strange phenomena on the Moon. Flashes of light, unidentified objects, strange structures. Ancient myths and legends. Who could have created the Moon? Secret NASA and Chinese research. Why is the Moon being studied so actively? Fasten your seat belts, because this will be the most mysterious flight to the Moon that will change the way you think about our satellite. Mysterious anomalies of the Moon. Something's wrong. The Moon seems like the perfect cosmic body, Earth's natural satellite. But the more we study it, the more unexplained facts surface. Lunar resonance. Why does the Moon sound like a bell? When the Apollo 12 mission launched a return module to the Moon, it hit the surface and caused a bell-like effect that lasted almost an hour. This is impossible for an ordinary rocky object. This means that the Moon could be hollow inside or have huge voids. Wrong density of the Moon. The Moon has a very low density, less than that of the Earth. This contradicts standard models of satellite formation. Some scientists believe there may be a huge metallic structure under the Moon's surface. Lunar flares and strange lights. For decades, astronomers have been recording strange flashes of light on the Moon. NASA has even created a special observation program. What are they? Gas eruptions? Electrical discharges? Or is it something else? These anomalies are just the beginning of our mystery. Let's dig deeper. The moon's artificial origin theory. Could the moon be artificially created? This idea sounds like science fiction, but some scientists, researchers, and even former NASA employees think it's possible. The main arguments. 1. The moon is too big for an Earth satellite. Compared to other satellites in the solar system, our moon is unusually large. To perfect orbit the moon is at a perfectly precise distance from Earth, creating the effect of a total solar eclipse. An accident? 3 metals and radioactive elements samples brought back from the moon contain rare metals that are difficult to explain in terms of standard models. One of the boldest views of the moon was proposed by Soviet scientists Mikhail Vassin and Alexander Sherbakov in the 1970s. They claimed that the moon was a huge ancient ship built by an unknown civilization millions of years ago. Is it possible that the moon is an abandoned space station? Mysterious structures and objects on the moon. There are strange structures on the moon. NASA photos show anomalous structures that resemble towers, domes, and even pyramids. Here's what was discovered. Tower of the Moon, a giant vertical structure 3 kilometers high. Moon domes look like man-made structures. Disguised craters, the bottom of some craters are too flat, as if they were machined. Who built these structures? Some scientists think it's just a play of light and shadows, but there is a belief that these objects could be the remains of an ancient base or station. Ancient legends of the moon. What do ancient texts and myths say about the moon? In the ancient myths of various nations, there are references to a time when the moon did not exist. Greek myths speak of the Doluni people, a tribe that lived before the moon appeared. Zulu legends claim that the moon was brought from the sky. Sumerian texts mention strange events related to the moon. Is it possible that the moon wasn't always there? What are NASA and China trying to hide? China's Chang mission and secret lunar explorations. China's lunar program has discovered new minerals and unusual radiation. Some claim Chinese satellites have detected anomalous objects on the moon. Why is this data not being published in full? There is a theory that the government is withholding information that there are traces of an ancient civilization on the moon. Is the moon the key to the secrets of the universe? We can see that the moon is not just a piece of rock in the sky. It is full of mysteries and riddles that can change our understanding of the universe. The main questions that remain open are: why is the moon so perfectly positioned? Where did the strange structures come from? Could the moon be an ancient spaceship? What do you think? Is it possible that the moon is an artificial structure? The idea that the moon might be an artificial object sounds like something out of science fiction, but it has some interesting points. Some of the anomalies, such as strange wobbles on impact, unusual density, and strange structures on the surface, really make you wonder. On the one hand, we have scientific explanations the moon was probably formed by a giant impact, and its hollow structure may be related to its geologic history. But on the other hand, some of the data from NASA missions raises questions, especially since the bottoms of some craters are suspiciously flat and shapes resembling man-made structures can be seen in the images. Of course, we don't yet have evidence that the moon is a spaceship or an ancient megastructure, but the very idea that we could be wrong about our understanding of the moon's history makes it incredibly fascinating. Perhaps future missions like Artemis and further exploration of the moon will help unravel its mysteries. What if the moon is not just a natural satellite, but something more than we can imagine? If you enjoyed the video, don't forget to subscribe, give it a like, and share this incredible discovery. The invisible shield that protects us. Imagine an Earth without a magnetic field, without protection from the solar wind, without a compass, without stable navigation. What if one day it disappeared or started behaving unpredictably? Every year, scientists record anomalies more and more often. The South Atlantic anomaly is expanding. The northern magnetic pole is rapidly drifting towards Siberia, and the field strength is decreasing. What is this, the beginning of a geomagnetic inversion or something completely new? The Earth's magnetic field is one of the most mysterious and important components of our planet. It is invisible, but vital. In this video, we take a fascinating journey deep into the Earth's core to understand. How is the Earth's magnetic field formed? Why is it weakening, and what is the South Atlantic anomaly? Is a pole shift possible in the near future? What will happen to mankind if the magnetic field disappears? Fasten your seat belts. We begin our dive into the deepest and most mysterious processes that shape our world. How does the Earth's magnetic field work? The magnetic field is created by geodynamo, the movement of molten iron in the Earth's outer core. These movements create electric currents, and the currents in turn generate a magnetic field. It extends far beyond the planet, forming the so-called magnetosphere, an invisible cocoon that protects us from the solar wind and cosmic radiation. Interestingly, the magnetic field is constantly fluctuating. It strengthens and weakens, changes shape, and even flips over. Scientific data confirms that magnetic inversions have already occurred in the Earth's history, when the North and South poles changed places. What is happening to the field today? Over the last 200 years, the strength of the magnetic field has decreased by about 9%. That's not just a statistic, it's a troubling symptom. Scientists are particularly concerned about the South Atlantic anomaly, an area over South America and the South Atlantic where the magnetic field is particularly weakened. It is in this region that satellites fell more often and the radiation impact on them increases. Some scientists believe this is a sign of an inversion that has begun. Others say it's a temporary anomaly. But a growing body of evidence suggests the magnetic field is behaving erratically, and the consequences could be serious. The poles are on the move. The magnetic North Pole, which was still in Canada at the beginning of the 20th century, is now rapidly moving towards Siberia. Its speed has more than tripled from 15 km or year to 50-60 km or year. Scientists from the U.S. Geological Survey and the Alvin Institute of Geophysics are watching this process with alarm. Such a shift could affect navigation systems, aviation, satellites, animal migrations, and even climate. And if the inversion really begins, we will be witnessing a grand but dangerous phenomenon. New alarming signals. The Earth's magnetic field, which for billions of years has protected life from cosmic aggression, is now beginning to behave strangely. Scientists from around the world are watching this process with alarm. Back in 2020, satellites of the European Space Agency's Swarm mission recorded serious deviations in the structure of the field. A particularly mysterious zone is the South Atlantic anomaly. Here, the magnetic field is weakened so much that spacecraft literally sag in their defense. Some of them even fail because of the increased flow of radiation. It's been called the Earth's weak spot. But what is even more surprising within this anomaly began to form a second point of minimum. That is, the area where the field practically disappears. This could be a sign that a geomagnetic inversion is not just possible, but has already begun. Pole drift, an acceleration not expected. The North Magnetic Pole is leaving Canada and rushing towards Siberia at a speed of up to 60 kilometers per year. For comparison, at the beginning of the XX century, its speed was only 15 kilometers per year. This process has accelerated so much that international services had to urgently update navigation maps and programs. But why is this happening? The magnetic field is created deep underground in the outer core, where liquid iron and nickel form giant currents. When those currents change, the magnetic field changes. And since we cannot look there directly, all that we see, this is only the surface manifestations of much deeper and still incomprehensible processes. The pole shift is already affecting aviation, navigation, and even the migration routes of animals. Some species of birds and sea creatures are losing their orientation. This may seem like a small thing, but at the level of the biosphere, it is a wake-up call. What if the magnetic field disappears? The complete disappearance of the Earth's magnetic field is a rare but theoretically possible scenario. Although in practice, it would likely just weaken greatly, the consequences of even a temporary disappearance would be catastrophic. Let's imagine there is no longer any magnetic shielding on the Earth's surface. What's in store for us? Radiation shock. Solar wind and cosmic radiation reach the surface unhindered. Ordinary magnetic storms become deadly. This leads to an increase in cancer, mutations in DNA, massive reproductive failures in animals and humans, collapse of satellite systems, navigation, meteorology, internet, military systems all operate through satellites. In the absence of a field, electronics overheat, atmospheric ionization increases, and satellites fail one by one. Power problems. Magnetic storms are already capable of causing power grid failures. If there is a strong inversion or the field weakens by a few percent, the consequences could include nationwide power outages, transformers failing, communications and internet outages, climate fluctuations. Although a direct link between the field and climate has not yet been proven, there is evidence that dramatic changes in temperature patterns and air mass circulation have occurred during past inversions. Psychophysiological impact. Some scientists and alternative researchers claim that the magnetic field affects brain rhythms, biorhythms, mood, and even time perception. When the field is weakened, anxiety, sleep disorders, and depression can increase. It's happened before. The history of geomagnetic inversions. Magnetic field inversions are not science fiction. They are a documented geophysical fact. Over the past 20 million years, the Earth's polarity has reversed more than 80 times. The last major inversion, the Bruns-Matsuyama inversion, occurred about 780,000 years ago. Then the north and south magnetic poles literally switched places. The transition took several thousand years. But there were also faster, shorter-term events, geomagnetic excursions. For example, the Lecampa event about 41,000 years ago lasted only a few hundred years. The field intensity dropped to almost 5% of normal. What's interesting, this event coincides with a number of climate anomalies and the extinction of some species. Some scientists even believe that this is when Neanderthals began to disappear, giving way to Homo sapiens. Humanity survived. But back then, it was not technologically dependent on power grids and satellites. Today, the situation is quite different. Magnetic field and technology on the verge of failure. Modern civilization means thousands of satellites, millions of kilometers of cables, sophisticated navigation and communication systems. All of this is vulnerable. Even a slight weakening of the magnetic field can cause massive GPS failures, especially in aviation and military applications, affect cell phones and the internet, increase errors in navigators in cars, airplanes, ships, disrupt financial systems and bank servers, endanger astronauts and manned missions into space. Polar regions, where the magnetic field is already weaker, are especially sensitive to these phenomena. It is there that disruptions in satellite communications and failures in electronics are already being recorded. Despite all the warning signs, mankind is already thinking about defense. Scientists, engineers, and international agencies are developing scenarios to adapt to a possible inversion or weakening of the magnetic field. Infrastructure protection. Magnetic shields on satellites. Many satellites are already being equipped with additional radiation shielding. In the future, if the field weakens, such measures will become mandatory. The development of special miniature magnetic fields around satellites is possible. Redirecting satellite orbits. If it is known that the magnetic field is weaker in a particular area, for example, the South Atlantic anomaly, satellites can be reorbited in advance, either temporarily or permanently. Underground storage and backup systems. Underground data centers, shielded from external radiation, are being established to protect critical information, especially government data. Medical adaptation. Magnetically shielded chambers. These technologies can be used in space, in underground laboratories, and in medical centers. The chambers shield against radiation and maintain a stable magnetic environment, which helps reduce stress and physiologic strain. Anti-radiation drugs. Scientists are working on substances that increase the body's resistance to ionizing radiation. This research is funded, among other things, in preparation for future space missions. Scientific monitoring and response. Monitoring networks. Worldwide agencies such as ESA, NASA, and university laboratories monitor geomagnetic activity 24 hours a day, 7 days a week. Rapid warning centers for storms and anomalies are established. Response protocols. Guidelines are being developed for energy companies, airlines, military, and rescue services. In the event of a magnetic anomaly, risks can be mitigated in advance. Shut down sensitive equipment, change routes, limit activities in dangerous regions. Magnetic field and biosphere. We're used to thinking of the magnetic field as something technical, but in fact, it affects the entire biosphere, including animals and possibly even humans. Animal migrations. Many species are oriented by the magnetic field. Birds, geese, pigeons, storks, sea turtles, salmon, bees, even bacteria. They have special cells or molecules in their bodies that are sensitive to the magnetic field. If it changes, animals can go off course, fail to find a breeding ground, or die along the way. Geomagnetic sensitivity in humans. So far, this question is controversial, but some scientists suggest that humans also sense the magnetic field subconsciously. There are hypotheses that changes in the geomagnetic environment can cause headaches and anxiety, sleep disturbances, decreased concentration, spikes in aggression or depression. In years of increased solar activity, heart attacks and traffic accidents are reported to increase. Does the magnetic field affect the climate? Official science has yet to give a direct link between geomagnetic changes and climate change. However, interesting correlations are emerging. During the LaCampa event 41,000 years ago, there were climate anomalies, cooling, and mass extinctions. As the field weakens, the inflow of cosmic radiation increases, which can change cloud cover and hence temperature. The magnetosphere is involved in protecting the atmosphere from ionization, affecting the processes on which the circulation of air and water depends. It is also worth noting that the magnetic field can interact with solar activity, and that, in turn, affects climatic processes on Earth. So far, these are just hypotheses, but more and more scientists are paying attention to them. Alternative hypotheses and mysteries. When it comes to magnetic fields, there are not only scientific theories, but also hypotheses that go beyond academic science. Magnetic field as a carrier of information. Some researchers believe that the field can preserve the fingerprints of evolution. That is, it is not just a protection, but a kind of energy memory of the planet. This idea sounds almost mystical, but finds support in theories about the holographic nature of the universe. Field and consciousness. Supporters of this idea claim, during strong geomagnetic storms, people have more vivid dreams, intuition increases, and unusual states of consciousness arise. There are even studies linking the level of geomagnetic activity with mass moods in society. Cosmic cycles. Some scientists hypothesize that changes in the magnetic field are due to the solar system passing through different parts of the galaxy. For example, through spiral arms where there is a higher density of stars and radiation. This may explain regular geomagnetic inversions and climate crises on the planet. Esoteric versions. In esotericism, there is the notion that the magnetic field restrains higher forms of energy, and its weakening would open a window of opportunity for a new era of consciousness. Such ideas are popular in spiritual circles and futurological theories. The magnetic field is not just a physical phenomenon. It is an invisible shell that has protected life on Earth for centuries. It's a cosmic barrier keeping chaos out of the atmosphere, but today, that shield is faltering. We are witnessing its instability. Perhaps an inversion is coming. Perhaps it's just a temporary anomaly. Science has yet to provide definitive answers. But one thing is certain: all life on this planet depends on this delicate, fragile structure. And the further we advance in technology, the more we realize we're vulnerable to it. Doesn't matter how powerful our computers and rockets become if the magnetic field disappears. The basis for stability disappears. But there is another side to this. We have the brains, the knowledge and the combined science to not just predict, but to act. We have a chance to not just survive, to adapt and become stronger. Today, we stand on the brink of change. We face not only a challenge, but also an opportunity to better understand how the Earth works, and maybe the whole universe. If you are close to science, if you feel at the greatness of the planet, if you want to know what will happen next, stay with us. There are more mysteries to come. And perhaps the most important discoveries are yet to come.
Sunsets are an amazing phenomenon that we are used to seeing on Earth. They vary in shades from golden, orange to purple, becoming a mesmerizing sight thanks to our atmosphere. But what do sunsets look like on other planets in the solar system? Where the atmosphere is made up of other gases and the laws of physics behave differently, we can observe something completely different. Let's dive into this unusual journey and find out more. Mars, a cold blue sunset. On Mars, sunsets are quite different from those on Earth. The red planet is known for its thin atmosphere, made up mostly of carbon dioxide, and its dust storms give everything on the surface a reddish hue. However, sunsets on Mars are colored a cool bluish color. This is because dust particles in the Martian atmosphere scatter blue light more efficiently than red light. Imagine the sun setting on the horizon, and everything around you is colored in shades of cool blue. It's a sight that is both mesmerizing and creates a sense of loneliness in this desolate world. Jupiter, swirls of red and brown. Jupiter is a gas giant, and it has no solid surface from which to view the sunset. But if you were at the level of its clouds, you would see something amazing. Jupiter's atmosphere is rich in hydrogen, helium, ammonia, and other compounds that create its famous stripes. Sunset on Jupiter is a succession of vivid red, brown, and golden hues mixed with an intense swirl of clouds. In the distance, flashes of lightning and storms complete the picture, turning the sunset into a true cosmic show. Saturn, golden and creamy hues. Saturn, with its rings, is often associated with splendor. Its sunsets are also marvelous. Saturn's atmosphere is made up mostly of hydrogen and helium, and when the sun sets behind clouds, the light diffuses to create soft golden cream hues. It's a sight that seems incredibly tranquil compared to stormy Jupiter. Imagine the shadows of Saturn's rings laying over the planet, adding even more magic to this picture. Venus, a hellish orange-yellow palette. Venus is known for its dense atmosphere made up of carbon dioxide and clouds of sulfuric acid. This makes sunsets on Venus quite unique. The thick atmosphere of scattered light creates an orange-yellow palette, but at the same time, visibility is extremely limited. Sunset on Venus resembles the dawn of hell. The light is bright, almost aggressive. The atmosphere of Venus is so dense that the light is distorted, creating a hazy glow. Titan, a fabulous combination of blue and orange. Titan, a satellite of Saturn, stands out among all celestial bodies with its thick nitrogen fog. Sunset on Titan seems like a fairy tale. The sky here takes on a bluish hue, smoothly changing to orange and pink due to the presence of organic molecules in the atmosphere. Imagine Saturn's rings shining through against this soft glow. This place is perhaps one of the most mysterious places to watch sunsets. Uranus and Neptune, ice blue sunsets. On Uranus and Neptune, the atmospheres contain a lot of methane, which absorbs red light and reflects blue light. Sunsets here are cold, almost icy, and colored in deep blue and turquoise hues. However, because of the vast distance from the sun, the light seems dim and the sunsets are long. slowly slipping away over the horizon. It's a veritable dance of light and shadows at the edge of the solar system. What happens on exoplanets? Now that we've explored sunsets within the solar system, let's look beyond it for a moment. Scientists have discovered thousands of exoplanets, worlds orbiting other stars. On these planets, sunsets can be quite unusual. For example, on planets with 2 or 3 suns, you can see several sunsets, one after the other. Imagine a sky that is encompassed by 3 stars at once, each coloring the horizon in its own unique hue. On an exoplanet like WASP-1b, where the atmosphere is incredibly hot, sunsets can be bright yellow or even green due to rare chemical elements. And on water worlds like those depicted in science fiction, sunsets can reflect off the ocean surface, creating a kaleidoscopic effect. Each sunset is unique, and its beauty depends on the atmosphere, gas composition, and distance from the star. They remind us how amazing and diverse our cosmos is. As we gaze at a sunset on Earth, we can imagine what wonders lurk on other planets and satellites. And who knows, maybe one day we will be able to not only imagine, but see these incredible sunsets with our own eyes. If you enjoyed our space journey to the sunsets of other planets, don't forget to subscribe to the channel. More amazing and informative stories about our world and beyond await you here. Give us a like, share the video with your friends, and be sure to press the bell so you don't miss new episodes. Your interest is our motivation.
Are we truly alone? Or are we just not listening carefully enough? Are we alone in the universe? Part 1: A planet under suspicion. 124 light-years from Earth. There is a planet unlike anything in our solar system. It's called K2-18b, 2.5 times the size of Earth, with a massive ocean, hidden beneath a thick hydrogen-rich atmosphere. And now, scientists have found something. In that atmosphere, a chemical fingerprint, one that on Earth is only produced by living organisms. Part 2: James Webb. A look through the universe. The James Webb Space Telescope is not just a camera. It's a machine that analyzes light from other worlds. It studied the atmosphere of K2-18b. Not by flying there, but by watching starlight, passing through the planet's gassy shell. And in that light were traces of something unexpected. A molecular signal. That, on Earth, usually means life. Part 3: Molecules and Excitement. Scientists detected traces of dimethyl sulfide on Earth. This molecule is produced by marine life, like plankton. But is it really a sign of life on another planet? No one knows for sure, even with perfect data. It could still be from something geological. Still, it's the strongest evidence of possible life we've ever seen. Part 4: We've been here before. This isn't the first time we've seen hints of life. On Mars, we thought we found microbes, but it turned out to be just chemistry on Europa. beneath layers of ice. There's an ocean that could be alive. Enceladus has geysers spraying something strange into space, over and over again. We find clues, hints, promises, but never a clear answer. Not yet. Part V. Our position. It's easy to get excited. Headlines love words like alien life and discovery, but science doesn't work that way. It's not about hype. It's about evidence. This isn't a press release. It's a process, careful, slow, and right now, we have something interesting, but not something certain. Not yet. Part 6. What if it's true? What if we're right? What if this molecule really does mean life? Then it wouldn't just be a discovery. It would be a revolution. We wouldn't be the center of biology anymore. We'd just be one of many strange stories, scattered across the stars. If life formed out there, it means life isn't rare. It means life is the rule, not the exception. It could be swimming through alien oceans, growing under different suns, dreaming maybe. Like we do. It would mean the universe is not empty. It's alive, and we are not alone. Part 7. What comes next? Scientists will keep watching. The James Webb Telescope will collect more data, more light, more clues. We'll scan the skies for more planets like K2-18b, worlds with oceans, with air, with potential. Other telescopes are coming too. Missions planned for the icy moons of Jupiter and Saturn, Europa, Enceladus, Titan, because sometimes the answers might be closer than we think. The search is just beginning. What is life? What do we even mean by life? Must it breathe, think, reproduce? Does it need DNA? Or just complexity and persistence? On Earth, life is made of carbon and water, but maybe out there, it's made of something else. Maybe it doesn't walk. Maybe it floats. Maybe it doesn't care that we exist. Maybe it's been there for billions of years, waiting. Conclusion. What it all means. Maybe we've found something, maybe not, but this isn't about aliens. It's about how far we've come. And how much we still don't know, the fact that we can analyze the air of a planet 124 light years away. That's incredible. IT means science isn't. IT means wonder is still possible. We may be alone, or we may not be, but we're asking the right questions, and we're finally learning how to listen for the answers. Our take, honestly. We don't make bold claims. We're not saying aliens are real, but we're also not saying it's nothing. We believe in data, in patience, in science. And what's happening right now, this slow process of watching, thinking, questioning, that is the discovery. Maybe there's life out there, maybe not. But either way, asking the question still matters, because when we ask, we grow, we reach. We remember that we're part of something way bigger than ourselves. If you've made it this far, you're probably one of the few who actually care. So thank you, and if this spoke to you, subscribe. We're just getting started.